Hi, I'm Paul Keoghan from Gktuition, and in this video I want to talk to you about statistics. Now the question that I've chosen to go through here is 2018 paper 2 question 7. In this question we're given the total rainfall and the total sunshine at Valencia in June of each year for a number of consecutive years. The first three parts of this question are relatively straightforward. For A part 1, it asked you to find the range of rainfall over the years that are specified. The range is just the most rainfall, the biggest minus the smallest, or in this case the most rainfall minus the least rainfall. The most rainfall of any year in June was 155 millimeters, the least was 47 millimeters. So if I subtract 155 minus 47, I get 108 millimeters of rain. So the range there was 108 millimeters. Part 2 then asks me which year had the most amount of rainfall. So you just need to look for the figure, the biggest figure along the rainfall column or the rainfall row, and in that case the worked out is 2003. And then for part 3 it asked you which year had the least amount of sunshine. The year that had the least amount of sunshine in June was 2002 because there was only 124 hours of sunshine in June. So there are the three answers to part A. In part B we're asked to write down the year that had the best weather in June. Now technically here there's no one right answer, so I've gone with 2006, but if you had went with a different year and you justified it appropriately, you could have gotten the marks. There's space in the marking scheme for justifying it appropriately. The one that makes most logical sense to me is 2006. And the reason you could say is that it had more sunshine in June than any other year, i.e. 239 hours, and it had less rain than any other year, i.e. 47 millimeters. In part C here, we're asked to write the rainfall data in increasing order and hence to find the median of rainfall. So you'll notice I've labelled them 1 to 10 and I've marked in from the smallest 47 to the biggest 155. And now you need to work out the median. The median is the middle number. But if there's an even amount of data, there's actually no piece of data, there's no number here, there's no amount of rainfall here that's actually in the middle between them. There's 10 figures. If I took this figure as my median, there's 4 figures to the left of it and 5 figures to the right of it. So that 94 is not the median. You can't take 101 as the median because there's 5 to the left of it and 4 to the right of it. So there's no one piece of data that is the median here. The median lies between the 5th figure and the 6th figure. This line represents the median because there's 5 figures to the left of it, 5 figures to the right of it. So the middle of the data is whatever's halfway between 94 and 101. So to get the median, you get the average of 94 and 101, which means you add them together and divide by 2. The average of 94 and 101 is 97.5 millimeters. So the median rainfall in that case was 97.5 millimeters of rainfall each June. Okay, for D part 1, we're asked to find the mean number of sunshine hours in June in Valencia over the 10-year period we've been given. In other words, just take the data for sunshine, add them all together and divide by the number of numbers. When you're getting mean, I advise you to always actually write that fraction out, just in case you make a mistake when you're doing the calculator work. So you add up all your numbers, divide by 10. So if you add them all up on the top, you get 1818 divided by 10, which means that the mean number of sunshine hours in June was 181.8 hours of sunshine. Okay, in D part 2, it asks me to work out for which years was the mean number of sunshine hours within 5% of the mean number of sunshine hours in Valencia. Now in D part 1, we worked out that the mean sunshine hours in Valencia was 181.8 hours. And we want to know which years were within 5% of this. So in order to do that, obviously the first thing I need to do is find out what is 5%. So if we multiply 181.8 by 0.05, that will tell me what 5% of the sunshine hours in Valencia is. And 5% of 181.8 works out as 9.09. In other words, I want to work out for which years was the mean number of was the sunshine data within 9.09 hours of the mean in Valencia. In other words, I take the mean in Valencia and I add on 9.09. I take the mean in Valencia and I subtract 9.09. So in any year that the sunshine hours was between 172.91 and 190.89, anything in between that is within 5% of the mean hours in Valencia. So if you look at your original table and you look at the data, clearly there's 3 years in which the sunshine hours lies between these two figures. The 3 years in this case is 2003, 2004 and 2005. So your final answer there are actually those 3 years. In part E, you're asked to work out the standard deviation of rainfall. Now you can just plug that into your calculator. If you just put in all the rainfall data, you'll be able to work out the standard deviation is 33.5 millimeters. Okay, for part F, we're asked to plot on a scatter plot the relationship between total rainfall and total sunshine. The x values, the rainfall represents the x values, the total sunshine represents the y values. So obviously my graph leaves a little bit to be desired, but yours should be as accurate as possible. So I've plotted my 10 different points here, and now I need to figure out what the relationship between sunshine and rainfall in June is. For part 2, I need to figure out which either plus 0.6, plus 0.1, minus 0.1 or minus 0.6, which one of those is the correlation coefficient for this graph. In order to figure that out, you should try and visualize where the line of best fit is. The line of best fit is a line that you can draw where roughly half of the figures are above it, half of the figures are below it. Now, first of all, you need to realize that it seems that roughly the more sunshine you have, the less rain you have. Like my year that had the most sunshine had the least amount of rain. But then in these years, say there's a number of years here where the sunshine was around 170, between 160 and 180. There was loads of those, and there seems to be a lot of rainfall. Like there was a lot of rainfall in those years relative to the years that had a lot of sunshine. So you should realize that there's clearly a negative relationship here. The more sunshine you have, in general, the less rainfall you have. If I was to draw a line of best fit for this graph, now I'm only just visualizing it myself, I think it looks roughly like that. But the thing you have to realize is that it's definitely a negative relationship. So certainly or can't be equal to plus 0.6 or plus 0.1. Minus 0.1 and minus 0.6 represent two variables that have a negative correlation, where if one is bigger, the other one is smaller. Clearly that's the case here. Now I need to distinguish between minus 0.1 and minus 0.6. If it was minus 0.1 is very close to 0. If the correlation coefficient or was 0, that means that the slope of that line would be 0. If the slope of the line was 0, it would be horizontal. So if a graph had a correlation coefficient of minus 0.1, it would be fairly flat. It would be very horizontal. This one is clearly not horizontal. So in this case, it seems it's a strong enough relationship, and the OR value, the correlation that I'm going to go with, is minus 0.6. Now, in order to do that, you didn't have to draw that line, but I just think it's easier. It's certainly easier for me to visualize what's going on when I draw that line. So if you're stating that the correlation coefficient is minus 0.6, they then ask you to explain that. That's a strong negative correlation. The largest value that could possibly be is minus 1. So I would refer to this is a strong negative correlation. A strong negative correlation. In other words, as one of them gets bigger, the other one gets smaller, and vice versa. So your marks for that, for part, I would have selected minus 0.6 and say that that's a strong negative correlation. There's actually scope there. You're allowed to say strong, or you could have said a medium negative correlation, because it's not really strong, but you'll get the marks either way. So I hope that video makes sense. If there's anything you're unsure of there, or you'd like me to clarify it, just let me know in class or send me an email and I'll try and explain it just a little bit differently.